Okay, guys, here we go. Day 2 in our statistics unit. Measures of central tendencies, dispersion, and population parameters. Measures of central tendencies you've done before. It's just mean, median, and mode. Dispersion and population parameters. You did a little bit of that in 9th grade, but we'll talk about it as we get to it here. All right, population. So population is the complete set of all subjects. So whatever it is that you want to make some calculations on, it means that you have all of the data. So if I wanted to know the average test grade for a trig test I gave you guys, I would be able to get the population because I would have all of your scores. But if I wanted to know what the average in New York State was for a trig test that was given, I wouldn't be able to have the population because I wouldn't be able to get every test. All populations have natural variability. Remember, natural variability is where everybody's not the same. The example I gave you yesterday was two people that are the same exact age, same gender, and if they go to the gym the same amount of days, do the same exact thing, it doesn't mean that they're both going to lose the same amount of weight. It's natural variability. Most of the time, a sample is taken to infer characteristics of a population, so to come up with a conclusion. So if anyone's been watching the Cuomo briefings, he said that we're gonna, be taking a random sample to do the antibody tests. That's because they can't get the population, they can't get everybody. So they take a sample to come up with the conclusions. Population parameters describe the population. So the mean, the standard deviation, which we're going to talk about today, that just shows how far data deviates from the mean, and the interquartile range, which is quartile 3 minus quartile 1. So we're going to look at all those today. All right, this is important. As the sample size increases, the variability is going to decrease because the more I have, and that's what it says here, the larger the sample, the closer we're going to get to what the real true mean and standard deviation might be. So we always want to have a big sample. That's super important. All right, so let's just review the central tendencies, which you already know. Mean is when we add everything up and divide by how many numbers we have. Median is when we list from least to greatest, and then we start chopping off from the low and the high end until we get one middle number. Or if you're left with two numbers in the middle, then we average those. Mean is used definitely when I want to calculate your average quarter grades, because you wouldn't want me to chop off like 105, right, like the highest grade you got. You might want me to chop off the lowest, but that's not the way it works. When would median be used? Median is used like when people are buying houses. So when people are buying houses, just one second. When people are buying houses, if it's usually the median price is listed based on the towns. The reason that median is used because if there's one house in that town that's like a mansion and it's worth $2 million, it's going to throw off what the average price would be for the rest of the houses. So we usually use median with things like that. Get rid of what's called the outliers, the numbers that are significantly larger or lower. Mode is when we list from least to greatest. I'm sorry, I'm getting distracted here because my husband's coming in with groceries. And I usually spray them down. Oh, all right, so the mode is most often. So M-O, M-O. I like to think of like toothpaste commercials when like they'll say most doctors prefer Crest. That's because maybe they only polled 3 doctors and 2 of them wanted Crest. And so they could say that. That's an example of mode. Range is the difference between the highest and the lowest. Okay, so let's go and look at just a review of measures of dispersion. You could just leave that there, I'll do it all after. All right, so dispersion. Dispersion is just looking at the spread of the data. And it says the spread of a set of data is used to describe the variability of the information. And this looks at just how different the numbers are. All right, so we have interquartile range, which is quartile 3 minus quartile 1. And we'll talk about the quartiles in a second. Standard deviation is the measure of how close all of the data is to the mean. How far do you deviate from the average? Okay, a box plot. A box plot, you guys did do in ninth grade, and I already have it made, but the way you would make it is just draw a line. That's the lowest, that's the highest. You draw a box in the middle. Here's the middle. This is your quartile 1, and this is your quartile 3, and that's your median. Okay, so let me move down a little bit. And sometimes they will call box and whisker plots too. Okay, so I'm going to help you make sense of this. What are these quartiles? Lower quartile is 25th percentile, median is the 50th percentile, and upper quartile is the 75th percentile. When you guys go to the doctor, ever since you were born, they measure how tall you are, they take your weight, and they plot it all on what's called a growth curve. And what they're looking for is to see, do you remain the same? Are you remaining in the same percentile as you grow? Like, it's okay if you're short, which means you would be in the 25th percentile. And it's okay if you're tall, which maybe you would be in the 75th, but they want to see, do you remain in those percentiles? And when kids fall off of them or there's dramatic changes, then it could be like a concern. So that's what these quartiles are. It's just what percentile ranking you fall in. And if you fall in the 75th percentile, you're taller than 75% of the kids. And if we were to line you up from 1 to 100, you would be number 75, with 100 being the tallest. Okay, so next, now we got to do some calculator stuff. So what I want you to do is get out your calculator or get out, have your app open on your computer. Now, I couldn't do a video teaching you like this and go back and forth to the calculator. I tried, but then it would stop on me. So I made a video, and that's where you have a link also. So you might want to stop this video right now. Look what time you're at, stop this video, and now go and click on the other video that I titled Calculator Instructions Day 2, something like that. So go to that now, and I'm going to show you how we're going to calculate the mean. They want the mean, which the symbol is X bar, and they want the population standard deviation, which I like to just say OX. It's a lowercase sigma, but I like to just say OX. Okay, so pause the video, and here's all the steps, and you can go to that and then come back to me. Okay, all right, so we're back. So we did the calculator, and we wound up with X bar being 83.7, and our standard deviation being 11.7. And it says, how do you interpret the standard deviation? Well, most of the data lies 11.7 points above or below the average, 83.7. So that's how we interpret that. Okay. Now let's look at this. So I just drew this out ahead of time because it's just easier for me to be a little bit neater. All right, it says what percent, so we have to be careful, we're going to give our answer as a percent, what percent of the scores were within one standard deviation of the mean? All right, so here's what we're going to do. We're going to take this information and we're going to plot it. So X bar is 83.7. Okay, and I just rounded that. They would tell you what to round to. And now if I want to go X bar plus one standard deviation, I'm going to do 83.7 plus 11.7, and I get 95.4. Then I'm going to do X bar minus one standard deviation, so 83.7 minus 95.4, and I got 72. Okay, and now we're going to look at our percentage. So how many of those scores are between 72 and 95? That's essentially what I'm looking at. So I go back up to the tippy top and I count up how many of those scores are in that area. And I got 13. So 13 out of 18. If I turn that into a decimal, right, I wind up with this 0.722, repeating, and now move the decimal 2 places to the right, and it says round to the nearest percentage, so 72% would be my answer on that one. Now let's look at what percent is 2 deviations away. So I'm essentially going to do the same thing we just did. I made the number line already, just so I could fill it in easily. So my x bar is 83.7. And x bar plus 1 deviation, so 83, we already did that on the other side, right? We got 95.4. Add another deviation on, 107.1. Subtract 1 deviation like we did before. Subtract another deviation. And there we go. So now I'm looking for what scores are between 60.3 and 107.1. So essentially I'm looking for 61, right? Up to 107. So go up to the top again and count up how many scores fall in that range. How many of those scores up there? And if you count them up, I got 17. So 17 out of 18, convert to a decimal, right? And then turn it into a percentage. And they want you to round to the nearest percent again. So 94%. Okay, so when we went 1 deviation from the mean, you do get a big chunk of the data, right? So we got 72%. When you go 2 deviations from the mean, 94%. So you're getting like almost all the data. Oops. Oh gosh. Okay, let's move on to the next one. So the bar shifted. You see how I put the blue there? So the bar shifted. So just move it over on your paper. Hopefully it's okay. All right, it says here's John's test scores and here's Mike's test scores. And I just want you to calculate the average. So you don't really have to do that list and spreadsheet thing if you don't want to. You could just add them up and divide by 5. So we could do that real fast. And we got 85 for this one. And we got 85 for this one. They both came out to be the same. But now it says, what can you predict about the standard deviation of their scores? So let's go back and look. So John has scores of 85, 84, 83, 86, 87. He's pretty darn consistent, right? But if we look at Mike's scores, Mike's like all over the place. 79, 98, 68, 94, and 86. So I would have asked you guys in class, like, what do you think is going to happen when I do go back and do my lists and spreadsheets and I try and come up with what the standard deviation is? So I think that you would tell me that John's standard deviation is going to be pretty small and Mike's standard deviation is going to be pretty large. All right, so now you guys are going to go back like I did in that calculator video, and you're just going to do your whole list and spreadsheets and enter the data. If you do that, the standard deviation for John comes out to be 1.414, and the standard deviation for Mike comes out to be 10.73, so like we expected it to be. Okay, and then they said do it to the nearest 10. So John, I need a different pen. This is a little crazy. John, standard deviation is 1.4. And Mike, standard deviation is 10.7. Alrighty. Okay, moving right along here. All right, number 3. So this one looks a little different because you have a second column, but that's not going to change how we do any of the work. So it says a small company has salaries of their 50 employees as given in the tables below. And we want to calculate the mean, and we want to calculate the standard deviation. All right, so there's going to be a video for this one as well, and it'll be for number 3. Okay, so you can pause right here and you can go watch that video and then come back to me. Okay, so we got X bar to be 42,060, and we got the standard deviation to be 16,560. The median was also right in there. The median was 32,000. Okay, it says why is the median considerably lower than the mean. So why is the mean 42,000 and the median is 32,000? Well, remember, the mean is going to include the outlier of 120,000. So therefore, it's going to pull the mean up, where the median is going to take that guy off. Okay? All right, and then let's answer this little question here about it. So it says, does more or less than 50% of the data fall within one deviation of the mean? So we're going to make our little chart again. Here's our X bar of 42,000. And then we'll do X bar plus one deviation, which is 56,628. And then X bar minus one deviation, 25,492. Okay, so we want to go up top now and see how many of those scores, or how many of those, salaries fall between 25,492. So if I go back up, I can't include that 25,000 because that's lower. And where am I going up to? I'm going up to 56,600, so that means I would only go up to 45,000. So it looks like we're just adding up these two numbers here, right? And if I add those two up, oh no, and we can include that guy too. Yeah, so if we add those up, we get 42. So 42 Okay, so 42 out of 50, we get 84%. All right, convert to decimal, and then convert to percentage. All right, just a couple more here. All right, so first one, I did it because I know you know how to do this. What is the student's test average? If I gave you those three tests, add them up, divide by 3, and you get an 84. But you do have to know how to do this number 5 here. It says the student scored an 82, 75, and 65 on 3 tests, and they have 1 test left. So that's why I'm going to call that one X. They want to know, is it possible for them to end up with an 80 on a test? So I'm going to add up the 3 I have plus X, which is the one I don't know, divide by 4, and set it equal to 80. So if we were in class right now, I would be asking you, what do you think we should do? And I'm pretty confident you would tell me to add those guys up. If I add those up, I get 222 plus X divided by 4. I'll set that equal to 80. And then from here, I think most of us know as well, we would cross multiply and get 222 plus X equals 320. Subtract, and we wind up with 98. So is it possible for them to have that average? Yes. Oh my gosh, okay. All right, 6, so I think we got 2 more. So this is a Regents question that was given, like the one that I just did with you. So it says that Julie averaged an 85 on the first 3 tests. So 85 plus 85 plus 85, right, that would average to 85. It says if she scores a 93 on each of the remaining tests, so plus 93 on each of her remaining tests. Now, I don't know how many 93s she's going to get. We want to know which one of those equations could tell me what her average is. So remember, you have to divide by how many tests you gave. So how many tests you took. So I have 3 85s plus some amount of 93s. And then she wants to wind up with a 90. Okay, so that would be choice 3. All right, and then I think we're not going to do 6. All right, so that's it, guys. And then your homework follows. I think it's right after this. And you can see there's a blank copy on the site there for you, but then here's all the stuff done out for you. Okay? All right, good luck.